Hi everybody, today we are going to be using trigonometric ratios. So one thing that we're going to use our trig ratios for is to find missing lengths of a right triangle. So I wrote out the steps for this first example. So when you're given your figure, the first thing that I always recommend doing is labeling your figure with O for opposite, A for adjacent, and H for hypotenuse. And remember, it's always in reference to the angle that we are given. So from this angle, I can see that this is the opposite side, so I'm going to label it O. I can see that this is the hypotenuse, so I'm going to label it H. And I can see that this leg is our adjacent angle, so I'm going to label it A. So now that we have our figure labeled, we have to create an equation using sine, cosine, or tangent. So now it's important that we know which parts we have to work with. So I can see that in this example, we will be working with the opposite side and the adjacent side. So you have to ask yourself which trig ratio uses opposite and adjacent. And of course that is tangent. So our formula is tangent of theta equals opposite or adjacent. So now I'm going to substitute the values that we have. We know that the angle we're using is 23 degrees. So tangent of 23 degrees equals opposite, which is x, over adjacent, which is 6. So step 3 says now all we have to do is solve for x. So I can see that here we can solve for x by multiplying both sides by 6. So we get x equals 6 times the tangent of 23 degrees. Now at this point, you can use your calculator and you can plug in 6 times the tangent of 23 degrees to get a decimal approximation. So when I plug this into my calculator and I round to the nearest tenth, I get 2.5. So the key here, once again, is understanding which parts of the triangle you're given so you can decide whether we should use sine, cosine, or tangent. From there, you're just substituting your angle and any side lengths you have and then solving for x. And then it's just plugging it into your calculator. All right, let's try another example together. So for this problem, we're working with that 54 degrees. So I can see that this is opposite, this is adjacent, and this is our hypotenuse. So the two things that we have are the adjacent side and the hypotenuse. So here we know that we are going to be working with cosine. So cosine of theta is adjacent over hypotenuse. So then we can say the cosine of 54 degrees equals x, which is our adjacent side, over 12, which is our hypotenuse. And then we can multiply both sides by 12, and we get 12 times the cosine of 54 degrees. Now from here, we're just going to use our calculator to get a decimal approximation, and you get 7.1. All right, in this last example, let's mark up our triangle again. So we're working with 40 degrees. So this is going to be our opposite side. This is our adjacent side, and this is our hypotenuse. So the two things that we'll be working with is opposite and hypotenuse. So I know that means that we'll be using sine. So we can say sine of theta is opposite over hypotenuse, and now we substitute values that we know. So the sine of 40 degrees equals x over 19. So x equals 19 times the sine of 40 degrees. And from here, we'll use our calculator to get a decimal approximation, and you should get 12.2. All right, go ahead and pause the video and give these 3 problems a try. All right, let's go ahead and check our work. So for example A, we are working with opposite and adjacent, so we're going to use tangent. So tangent of 31 degrees is x over 10, and if you solve and use your calculator, you should get approximately 6.0. For example B, we're working with the opposite and the hypotenuse, which will be sine. So we have sine of 40 degrees equals x over 20, so x is approximately 12.9. And for this last one, it's a little bit tricky. We are working with the adjacent and the hypotenuse, so it's cosine. So we have cosine of 63 is 23 over x. So the first thing we need to do is multiply both sides by x. And then from there, we have a second step. We actually have to divide both sides by the cosine of 63. So this is actually what you're going to plug into your calculator, but it's just the same as multiplying by a trig function. We're just dividing by cosine of 63, and you should get approximately 50.7. Okay, so the other thing that we can use trig ratios for today is to actually find a missing angle rather than a side. So when we're finding an angle, we have to use what's called an inverse function. So inverse functions look like this. It looks like they're being raised to the power of -1, but this is just a symbol for an inverse function. So if you have something like this, sine of theta equals a over b, the way you can solve for theta is saying the arc sine of a over b. So you essentially swap your angle with your ratio, and then you use arc sine. That's how we read the inverse function. So same thing here. If we have the cosine of theta equals a over b, and we're trying to solve for our angle, we swap the values and we use arc cosine. That's our inverse cosine function. And if we have tangent of theta equals a over b, we can say that theta equals arc tangent of a over b. So you swap the values and you use the inverse function. This is something that your calculator will be able to do, but you still need to be able to show that you are using it in your work. So let's give it a try. When we are finding an angle of a right triangle, we're still going to start the same way. We're still going to label our triangle with opposite, adjacent, or hypotenuse. So in this problem, we're working with angle x. So I can see this is the opposite side, and this is our hypotenuse. So now we're going to create our equation, just like we did before. Since we have opposite and adjacent, I know that we're going to be working with sine. So we'll say sine of x equals 15 over 17, opposite over adjacent. So now at this point, we are trying to find the angle. So this is when we're going to swap the values and use arc sine. So we can say arc sine of 15 over 17 equals x. Now this will allow us to find that angle. Now your calculator has a button for arc sine. It's typically right above your sine button, but this is something where now all we have to do is plug it into your calculator to get a decimal approximation. And for this problem, we should get roughly 61.9, and since it is the angle, we have to say degrees. And there you go. Okay, let's try one more example together. So here, let's start by labeling our figure. So we're working with the theta. So this is going to be the opposite side, and this is our adjacent side. So I can see that we're going to be working with tangent. So tangent of theta is opposite, which is 8, over adjacent, which is 5. Now, since we're finding the angle, we swap the values and we use our inverse function. So arc tangent of 8 over 5 equals theta. And now when we plug this into our calculator, it will tell us what our angle is. So the arc tangent of 8 over 5 is equal to, we will actually get 58.0 degrees if you round it to the nearest tenth. So remember, if we are finding an angle, if it's the angle that we don't know, we're going to set up our equation in the same way, but the only way we can solve for that angle is by using our inverse function. Okay, go ahead and pause the video and give these last two a try. See if you can find for those angles, and we can call them theta. Okay, so let's have a look. For example A, we are working with the opposite and the hypotenuse, so that means we'll be working with sine. So sine of theta is 51/55, so that means that theta is equal to the arc sine of 51/55, which if you plug into your calculator and round properly, you should get 68.0. For part B, we're working with the opposite and the adjacent side, so we're going to use tangent. Tangent of theta is 29/38. Since we're finding theta, we can say theta equals arc tangent of 29/38, and your calculator will give you the decimal approximation of 37.3 degrees. Do make sure you have degrees for both of these answers because you are finding an angle. All right, that is all for today. Thank you for watching.